अब यो क्वेसन प्रुभ गर्न हामी एउटा क्युब बनाऊ। यो क्युब फर्म गर्छौँ हामी यसरी। थ्री डी फिगर बनाउने कोसिस गर्यौँ। यो जेड एक्सिस, यता एक्स एक्सिस अनि यता वाई एक्सिस भयो। दिस इज द origin. Suppose that cube meets x axis at A, y axis at B and z axis at C. Let this point be D and this be E and this be F and this be G. Now there are four diagonals in a cube which can be shown in this way. OG one diagonal, CD is another diagonal, FB is another diagonal, and the last one is diagonal AE, which is very difficult to show here, but we can join. If we can make this by joining, we can show the diagonal AE by joining dotted line, which is impossible to show here. And suppose there is another line PQ which makes angles alpha, beta, gamma, delta with four diagonals of a cube. Now we explain about the figure in this way. Consider a cube. Consider a cube having one of the corner as origin and three adjacent edges OA equals to OB equals to OC equals to AC. यो तीनटा एडजेसेंट साइड को लेंथ OA equals to OB equals to OC equals to A मानौं. Then the coordinates of the corner, the coordinates of the corner points of a cube O, A, B, C, D, E, F and GB, A, 0, 0, 0, A, 0, 0, 0, A. In this way we can show in figure also. A, 0, 0, and this is a point lying on y-axis, that's why its coordinate be 0, A, 0, and the point C lies on z-axis, so its coordinate be 0, 0, A, and point D on xy plane, that's why the coordinate of point D be A, 0, and this point E lies on the yz plane, that's why its coordinate is 0, A, and the point F lies on the xz plane, that's why its coordinate is A, 0, A, and this is a point having coordinate A, A. Okay, D, E, F, A, this is the point A, this is point P, and this is point C. Now coordinate of D is a comma 0, coordinate of EB 0 comma a, coordinate of FB a0 a, and a comma a respectively. Then from figure we have OG equals to root over, here O being the origin, so its coordinate is 0 comma 0 comma 0. Now by distance formula we have OG equals to a minus 0 square plus a minus 0 square plus a minus 0 square. Therefore OG equals to a root 3. But in a square all the diagonals are of equal length. That's why in a cube we have OG equals to CD equals to FB equals to AE. Therefore OG equals to CD OG equals to CD equals to FV equals to AE equals to a root 3. Okay. Consider a line consider a line PQ having dishes LMN. एउटा लाइन PQ लियो हामीले जसका डाइरेक्सन कोसाइन LMN सपोज गर्यौं. Suppose this is a line PQ having direction cosine LMN. एउटा लाइन PQ छ जसका डाइरेक्सन कोसाइन LMN छन् भनेर हामीले सपोज गर्यौं. Okay. Suppose that line PQ makes angles alpha, beta, gamma, delta with 4 diagonals. 4 diagonals OG, CD, FB and AE respectively. अब हामीले के सपोज गर्यौं भन्दा एउटा यो कुनै लाइन छ जसले यो चारवटै OG सँग अल्फा बनायो अनि CD सँग बीटा बनायो अनि FB सँग गामा and AE सँग डेल्टा बनायो भनेर हामीले सपोज गर्यौं. Now we have to find the direction cosine as we know that the direction cosines of PQ are LMN. So we have to find the direction cosine. We have to find the direction cosines of the diagonals OG, CD, FB and AE. Now let us find the direction cosine of OG. Now the direction cosines of OG are a minus 0 by a root 3, a minus 0 by a root 3, a minus 0 by a root 3, x2 minus x1 by OG, y2 minus y1 by OG and z2 minus z1 by OG. Yesterday we talked about when there are हिजो हामीले डिस्कस गरे अनुसार जतापट्टि a धेरै छ त्यतापट्टिको कोअर्डिनेटलाई x2 y2 z2 सपोज गर्दाखेरि हाम्रो नेगेटिभ भ्यालु आउँदैन. कहिलेकाहीँ नेगेटिभ आए पनि आन्सर मिल्दैन भन्ने हैन. फर हाम्रो सजिलोको लागि फर सिम्प्लिसिटी वी क्यान टेक द कोअर्डिनेट्स अफ point G as x2 y2 z2 and the coordinates of the point O as x1 y1 Z1. In this way, the direction cosines of OG are a minus 0 by a root 3, a minus 0 by a root 3, a minus 0 by a root 3. That is 1 by root 3, comma 1 by root 3, comma 1 by root 3. In this way, we can find the direction. We found the direction cosine of OG as 1 by root 3, 1 by root 3, 1 by root 3. Similarly, the dishes of CD are यस्तै तरिकाले निकाल्दाखेरि CD का डाइरेक्सन कोसाइनहरु a माइनस यो भनेको 1 by root 3 comma 1 by root 3 comma minus 1 by root 3. The dishes of FB are अब f र b को हेर्दाखेरि यो माइनस यो गर्दाखेरि a minus 0 1 by root 3 भयो, अर्को minus 1 by root 3 भयो र अर्को a minus 0 I mean 1 by root 3 and the dishes of AE are 1 by root 3 minus 1 by root 3 comma 1 by root 3 comma 1 by root 3. Okay, after that, since the line PQ makes angle, since the line PQ makes an angle alpha with the diagonal OG, so we have cos alpha equals to L into 1 by root 3 plus M into 1 by root 3 plus N into 1 by root 3. Therefore, cos alpha plus equals to L plus M plus N divided by root 3. Similarly, cos beta equals to L into 1 by root 3 plus M into 1 by root 3 plus N into minus 1 by root 3. On simplification yields cos beta equals to L plus M minus N upon root 3. Cos gamma equals to L into 1 by root 3 plus M into minus 1 by root 3 plus N into 1 by root 3. Therefore, cos gamma equals to L minus M plus N upon root 3, and cos delta equals to L into minus 1 by root 3 plus M into 1 by root 3 plus N into 1 by root 3. Therefore, cos delta equals to minus L plus M plus N upon root 3. Thus, we have obtained cos alpha, cos beta, cos gamma and cos delta. यसरी हामीले चारवटैको भ्यालु निकाल्यौं. Now, substituting all these values in the LHS of the question. Now, the LHS of the question is cos square alpha plus cos square beta plus cos square gamma plus cos square delta. यो substituting the values of cos alpha, cos beta, cos gamma, and cos delta in LHS, we get this. Now, अब यो सबको स्क्वायर खोल्दाखेरि 1/3 एज अ होलमा कमन आयो, L plus M plus N स्क्वायर प्लस L plus M minus N को स्क्वायर प्लस L minus M plus N को होल स्क्वायर प्लस माइनस L plus M plus N को होल स्क्वायर, यसो भयो। किनकि यो सबैमा √3 को स्क्वायर 3 भयो र एलसिएम हाम्रो 3 आयो। दिस इक्वल्स टु 1/3 होल स्क्वायर खोला अब L स्क्वायर प्लस M स्क्वायर प्लस N स्क्वायर प्लस 2LM प्लस 2MN प्लस 2NL, फर्स्ट को सक्यो। सेकेन्ड L स्क्वायर प्लस M स्क्वायर प्लस N स्क्वायर प्लस 2LM minus 2MN minus 2NL plus L square plus M square plus N square, थर्ड को minus 2LM minus 2MN plus 2NL plus L square plus M square plus N square minus 2LM plus 2MN minus 2NL. Okay, so we know that the value of L square plus M square plus N square equals to 1. So we can separate them by putting inside the small bracket. Here we have then 2LM 2MN cancel भयो, similarly 2NL पनि यहाँ cancel भयो, similarly यो 2LM पनि cancel भयो, 2MN पनि cancel भयो, यो सब cancel भयो. In this way we have 1/3 into 4 into L square plus M square plus N square. त्यहाँ चारवटा L square M square N square को सम भएकोले यसो आयो, and we know that this into 1 यो L square plus M square plus N square को भ्यालु 1 हुन्छ, यसैले 4/3 प्रुभड, हामीले प्रुभ गर्नुपर्ने यही थियो. In this way we have shown that the sum of the cos square alpha plus cos square beta plus cos square gamma plus cos square delta equals to 4/3. Find the direction cosines element of two lines which satisfy the equations. अब हामीलाई दुईटा इक्वेसन दिएको छ, यो दुईटा इक्वेसनको हेल्प लिएर एउटा लाइनका डाइरेक्सन कोसाइन्स निकाल्नु पर्ने छ. अनि सँगसँगै कहिलेकाहीँ यो डाइरेक्सन कोसाइन पनि निकाल भन्छ र अल्सो फाइन्ड द एंगल बिट्विन देम भन्ने क्वेसन पनि आउँछ. पहिला हामी यसका डाइरेक्सन कोसाइन निकालौँ, डाइरेक्सन कोसाइन निकालिसकेपछि we can find the angle between the lines whose direction cosines are given. Now first of all, right here the given equations are L plus M plus N equals to 0, let it be 1, that is अब यसबाट L वा M N जसको कुनै एउटाको भ्यालु निकाल्दियौ. L equals to minus M minus N. You can also find the value of M equals to minus L minus N or the value of N equals to minus L minus M, जुन निकाले पनि हुन्छ. And given equations are this, and 2LM minus MN plus 2NL equals to 0. Let it be equation 2. Using 1 on equation 2 yields 2M into minus M minus N minus Mn plus 2N into minus M minus N equals to 0, or minus 2M square minus 2Mn minus Mn minus 2Mn minus 2n square equals to 0. अब यसलाई सिम्प्लिफाई गरेर दुईटा इक्वेसन आउँछ or minus 2m square minus 5mn minus 2n square equals to 0 or 2m square plus 5mn plus 2n square equals to 0. अब यसलाई सिम्प्लिफाई गरौँ फ्याक्टराइज गरौँ or 2m square plus 4mn plus mn plus 2n square equals to 0 or 2m कमन आएपछि m plus 2n plus n कमन आएपछि m plus 2n equals to 0. Therefore m plus 2n into 2m plus n equals to 0. Either m plus 2n equals to 0, let it be equation 3, or 2m plus n equals to 0, let it be equation 4. Now solving equation 1 and 3 by using cross multiplication rule, we get the direction cosines of the line element, and similarly solving equation 1 and 4 we get another set of direction cosines. Okay, now solving equation 1 and 3 by solving equation 1 and 3 by cross multiplication rule. Cross multiplication rule लाएर सल्भ गरौँ. 1 फर्स्ट इक्वेसन का एलिमेंट का कोफिशिएंट लाई लेखौं 1 1 1. अब इक्वेसन 3 का एलिमेंट का कोफिशिएंट लाई लेखौं. यहाँनिर l को टर्म छैन, सो वी कैन सपोज द कोफिशिएंट अफ l एज 0. कोफिशिएंट अफ m is 1 and the coefficient of n is 2. अब फर्स्ट दुईटालाई रिपिट गरिदिउँ. अब अरु मेथड पनि हुन्छन्, अब जुन सजिलो लाग्छ त्यो गर्दा पनि हुन्छ. 1 1 अपवर्ड मल्टिप्लाई गर्दा नेगेटिभ सम्झिनको लागि सजिलो भयो. यसको माइनस माइनस सम्झिने. अब यो फर्स्ट को लाई हामी l अपन राख्छौं. l अपन समथिङ, यो भनेको m अपन, यो लाई n अपन. दैट इज l अपन 2 minus 1 equals to m अपन 0 minus 2 equals to n अपन 1 minus 0. That is l अपन 1 equals to m अपन minus 2 equals to n अपन 1 equals to root over l square plus m square plus n square divided by root over 1 square plus minus 2 square plus 1 square. That is l upon 1 equals to m upon minus 2 equals to n upon 1 equals to 1 upon root over 6. Therefore, from first and last two relation, first and last two relation, from and first and last relation, from first and last relation, l upon 1 equals to 1 upon root 6 implies l equals to 1 by root 6 from second and last ratio. Second and last relation. M upon minus 2 equals to 1 upon root 6 implies m equals to minus 2 by root 6, and from last two ratio n upon 1 equals to 1 by root 6 implies n equals to 1 by root 6. In this way, we have obtained the direction cosines of a line as hence the required dishes of a line are 1 by root 6 comma minus 2 by root 6 comma 1 by root 6. यसरी हामीले एउटा लाइनका डाइरेक्सन कोसाइनहरू निकाल्यौं. अब सिमिलरली सल्भिङ इक्वेसन 1 and 4 by cross multiplication rule, we can get the another set of direction cosines. Again, solving equation 1 and 4 by cross multiplication rule, फेरि इक्वेसन 1 र 4 लाई सल्भ गरौं. इन द सिमिलर वे, फर्स्ट इक्वेसन का एलिमेन्ट का कोएफिसिएन्ट 1 1 1 छन्, अनि फोर्थ इक्वेसन का कोएफिसिएन्ट मा यहाँनिर l को टर्म छैन, त्यही भएर हामीले 0 लिन्छौं. 0 2 1 फर्स्ट दुईटालाई रिपिट गर्दियौं. 1 0 1 2 अब क्रस मल्टिप्लाई गरौं. यो मल्टिप्लाई हामी l को अपन मा लेख्छौं, यो m अपन and this is n अपन. Therefore, here we have l upon 1 minus 2 equals to m upon 0 minus 1 equals to n upon 2 minus 0. That is l upon minus 1 equals to m upon minus 1 equals to n upon 2 equals to root over l square plus m square plus n square upon root over minus 1 square plus minus 1 square plus 2 square. That is l upon minus 1 equals to m upon minus 1 equals to n upon 2 equals to 1 upon root 6. Then l upon minus 1 equals to 1 by root 6 implies l equals to minus 1 by root 6. M upon minus 1 equals to 1 by root 6 implies m equals to minus 1 by root 6, and n upon 2 equals to 1 by root 6 implies n equals to 2 by root 6. Hence, the required direction cosines of a line are minus 1 by root 6 comma minus 1 by root 6 comma 2 by root 6. अब यहाँनिर हामीले माइनसले मल्टिप्लाई गर्यौं भने we get another set of direction cosines, like नेगेटिभ लाई यहाँनिर पोजिटिभ भ्यालुहरु आउलान्. त्यसैले in this way we have obtained the direction cosines of line are minus 1 by root 6, minus 1 by root 6 and 2 by root 6. अब यहाँनिर हामीले माइनसले मल्टिप्लाई गरेको भएपछि हाम्रा डाइरेक्सन कोसाइनहरु 1 by root 6 comma 1 by root 6 comma minus 2 by root 6 आउँछन्. त्यो लेख्दा पनि सही मानिन्छ और यो पनि ठीक छ. अब कहिलेकाहीँ एंगल निकाल्न पनि सोध्न सक्छ हामीले. अब यसको एंगल निकालौं. The direction dishes of two lines are 1 by root 6 comma minus 2 by root 6 comma 1 by root 6 and minus 1 by root 6 comma minus 1 by root 6 comma 2 by root 6 अब दुईटा लाइनका डाइरेक्सन कोसाइन यस्ता आयो हामीले भर्खरै जुन प्रुभ गर्यौं इफ थीटा बी द angle between the lines, if theta be the angle between the lines, then we have cos theta equals to L1 L2 L1 L2 plus M1 M2 minus 2 by root 6 minus 1 by root 6 M1 N2 plus N1 N2 1 by root 6 into 2 by root 6. This equals to minus 1 plus 2 plus 2 divided by 6 equals to 3 by 6 equals to 1 by 2. Therefore cos theta equals to 1 by 2. Hence theta equals to 60 degree. This completes your answer. अब यसरी कहिलेकाहीँ हामीलाई यही क्वेशनमा solve the two equation and find their direction cosine, also find the angle between them भन्यो भने we can use this formula cos theta equals to L1 L2 plus M1 M2 plus N1 N2 भन्ने फर्मुला युज गरेर यसरी क्याल्कुलेट गरेर एंगल बिट्विन देम पनि निकाल्न सकिन्छ. Now projection of a line segment. अब हामी यो प्रोजेक्सन भनेको यसको बारेमा डिस्कस गरौँ. प्रोजेक्सन भनेको जस्तो मानौँ फर द केस अफ पोइन्टका केसका लागि जस्तो कुनै एउटा पोइन्ट छ पी, यो पोइन्टको प्रोजेक्सन निकाल भन्यो कुनै लाइनको अलङमा भनेपछि यो पोइन्ट पीबाट परपेन्डिकुलर ड्र गर्यौं. यसरी कुनै लाइन सपोज यो एबी छ, एबी लाइनमा पोइन्ट पीबाट परपेन्डिकुलर ड्र गर्यौं भने सपोज यो पी Q is the foot of perpendicular. Then this point Q is called the projection of the point P on the line AB. अब कहिलेकाहीँ हामीलाई लाइनको प्रोजेक्सन के हो त? लाइनको प्रोजेक्सन कसरी निकाल्ने भन्दा सपोज देयर इज अ गिवन लाइन AB, एउटा लाइन AB छ र अर्को लाइन छ PQ. Now we have to find the projection of line PQ on the another given line AB in such a way that point P बाट यसरी परपेन्डिकुलर ड्र गरौँ. सपोज PL र point Q बाट पनि के गर्यौं QM परपेन्डिकुलर ड्र गर्यौं. And point L and M are the foot of perpendiculars of the point P and Q. Then this LM is known as the foot of is the distance between two foot of perpendiculars. In this way LM equals to projection of PQ on AB. Essentially projection of the line PQ on another given line AB is LM, which is in this way LM equals the projection of PQ on AB हुन्छ. Now we are going to find the projection of the line joining the points AP x1 y1 z1 and qx2 y2 z2 on the line AB whose direction cosines are given. So find the projection. Find the projection of the line joining the points x1 y1 z1 and x2 y2 z2 on a line whose direction cosines, whose dishes are L, M, N. अब दुईटा पोइन्ट को दुईटा पोइन्ट जोड्ने लाइनको प्रोजेक्सन निकालौँ त्यस्तो लाइनमा जसका डिरेक्सन कसाइनहरू एलएमएन गिभन छन्। अब फर दिस यसका लागि कन्सिडर अ लाइन AB. Consider a line AB whose direction cosines are supposed to be LMN. Let P x1 y1 z1 and Q x2 y2 z2 be any 2 point in space. We join P and Q and draw PL and QM perpendicular on the line AB. Also, we draw PR perpendicular on QM. Suppose that this line makes an angle alpha with AB, then angle QPR will also be alpha, being corresponding angle. अब यही कुरालाई एक्सप्लेन गरिदिउँ। Consider a line AB having dishes LMN. Let Px1 y1 z1 and Qx2 y2 z2 be any 2 points, be any 2 given points in space. We join PQ so that PQ equals to R equals to root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. We draw PL and QM perpendiculars on the line AB. Suppose that the line PQ makes an angle alpha with, we draw PL and QM perpendiculars on the line AB. Suppose that the line PQ makes an angle theta with the line AB. Then from figure projection, then from figure LM equals to projection of PQ on AB. भर्खरै हामीले डिस्कस गरौँ LM भनेको लेन्थ projection of PQ on AB, where L and M are the foot of perpendiculars drawn from the points P and Q. कुनै पनि लाइनको गिभन लाइनको एन्ड पोइन्टबाट पर्पेन्डिकुलर ड्र गर्दाखेरि आउने जुन यो फुट अफ पर्पेन्डिकुलरहरूको बिचको लेन्थ छ LM, this LM is known as the projection of the line. Okay, in this way LM equals to projection of PQ on AB. That is, in figure LM equals to PR equals to projection of PQ on AB. LM भनेको यहाँ PR पनि छ, त्यसैले PR equals to LM equals to projection of PQ on the line AB. From triangle QPR, from triangle QPR, cos we have cos theta equals to PR upon PQ. Therefore, PR equals to PQ cos theta. Let it be 1. Again, the dishes of line PQ are x2 minus x1 by r, y2 minus y1 by r, z2 minus z1 by r. Then cos theta equals to L into, अब यहाँनिर हामीले PQ का डाइरेक्सन कोसाइनहरु निकाल्यो। अब cos थीटा को भ्यालु निकालौं त। यदि दुईटा लाइनको बीचको एंगल थीटा दिएको छ भने PQ ले AB सँग बनाएको एंगल थीटा हो हैन। त्यसैले PQ का डाइरेक्सन कोसाइन पनि हामीलाई थाहा छ, भर्खरै निकाल्यौं। AB का डाइरेक्सन कोसाइन LMN छन् भने यहाँनिर cos थीटा इक्वल्स टु L1 L2 प्लस M1 M2 प्लस N1 N2 भन्ने फर्मुला लगाउँ। त्यसपछि cos थीटा को भ्यालु आउँछ। इन दिस वे वी हैव cos theta equals to L into x2 minus x1 by r plus m into y2 minus y1 by r n into z2 minus z1 by r. Now from 1 we have PR equals to PQ भनेको r छ, cos theta को भ्यालु राख्दियौ। L into cos x2 minus x1 by r plus m into y2 minus y1 by r plus n into z2 minus z1 by r. On simplification yields, therefore PR equals to LM equals to L into x2 minus x1 plus m into y2 minus y1, यहाँ r LCM आएर योसँग क्यान्सल भयो, y2 minus y1 plus n into z2 minus z1. Hence the projection of the line joining the points x1 y1 z1 and x2 y2 z2 on a line whose dishes are LMN equals to L into x2 minus x1 plus m into y2 minus y1 plus n into z2 minus z1. In this way, projection भनेको एउटा length हो. Now the question is here. Find the projection of the join of the pair of points 3, minus 1, 2 and 5, minus 7, 4 on a line joining the points 0, 1, 0 and 1, 3, 7. अब यो दुईटा पोइन्ट जोड्ने लाइनको प्रोजेक्सन अर्को लाइन अन अ लाइन, दिस इज द इम्पोर्टेन्ट थिङ। अन अ लाइन भन्यो भने त्यो लाइनका हामीले डाइरेक्सन कोसाइन निकाल्नु पर्ने हुन्छ जहिले पनि। अन अ लाइन भन्नुको मिनिङ त्यही लाइनका डाइरेक्सन कोसाइन थाहा हुनुपर्छ। अब गिवन पोइन्ट्स भनेको हामीले x1 y1 z1 को रूपमा x1 y1 z1 यो पोइन्ट र x2 y2 z2 को रूपमा यो पोइन्ट लिन सक्छौं। और एनी यो दुईटामा कुनैलाई पनि x1 y1 z1 र x2 y2 z2 लेट गर्न मिल्छ। अब अन अ लाइन भन्यो भने यो दुईटा पोइन्ट जोड्ने लाइनको डाइरेक्सन कोसाइन निकाल्नु पर्ने हुन्छ है। त्यसैले let the given points be x1 y1 z1 equals to 3, minus 1, 2 and x2 y2 z2 equals to 5, minus 7, 4. Also let the another also let the given another set of given points be a 0 1 0 and b 1 comma 3 comma 7. Now the direction cosines अब हामीलाई प्रोजेक्सन निकाल्न अन अ लाइन भनेको हुनाले ए र बी दुईटा पोइन्ट जुन दिएको छ यसको डिरेक्सन कसाइन निकाल्नु पर्ने हुन्छ। त्यसका लागि वी हेभ द फर्मुला x2 minus x1 by ab, y2 minus y1 by ab and z2 minus z1 by ab। त्यसैले फर्स्टमा हामी नाउ ab इक्वल्स टु रुट ओभर x2 minus x1 1 minus 0 को स्क्वायर प्लस 3 minus 1 को स्क्वायर प्लस 7 minus 0 को स्क्वायर हुन्छ यो, and this equals to root over 1 plus 4 plus 49 equals to root over 54. Therefore AB equals to root over 54 equals to 3 root 6. Then this is direction cosines of the line joining the points, direction cosines of the line joining the points, joining the given points भनौं A and B. Then the direction cosines of the line joining the given points A and B are x2 minus x1 1 minus 0 by 3 root 6 comma 3 minus 1 by 3 root 6 comma 7 minus 0 by 3 root 6, that is 1 by 3 root 6 comma 2 by 3 root 6 comma 7 by 3 root 6. We have the projection of the line joining the points 3 comma minus 1 comma 2 5 comma minus 7 comma 4 on a line whose dishes are 1 by 3 root 6 comma 2 by 3 root 6 comma 7 by 3 root 6 on a line whose dishes are this and this equals to L into 1 by 3 root 6 into x2 minus x1 plus 2 by 3 root 6 into y2 minus y1 plus 7 by 3 root 6 into 4 minus 2 equals to 2 by 3 root 6 minus 12 by 3 root 6 plus 14 by 3 root 6. LCM 3 root 6 on simplification 2 minus 12 plus 14 4 by 3 root 6, which is the required answer, which is the required projection. Which is the required projection of the line joining the given points on a line whose dishes are 1 by 3 root 6, 2 by 3 root 6 and 7 by 3 root 6. The projection of a line on the axis are 6, 2, 3. Then find the length of line and its direction cosines. एउटा लाइनको डिरेक्सन प्रोजेक्सन दिएको छ। अब त्यो लाइनको हामीले लेन्थ र डिरेक्सन कसाइन निकाल्नु पर्यो। कन्सिडर अ लाइन एबी, हामीले सपोज एउटा लाइन PQ सपोज गऱ्यौँ जसका एन्ड पोइन्टहरू P(x1, y1, z1 र अर्को पोइन्ट Q(x2, y2, z2 छ। अब हामीले के गरौँ यो PQ लाइनको एन्ड पोइन्टबाट परपेन्डिकुलर ड्रन गऱ्यौँ सो द्याट LM इज द प्रोजेक्सन अफ PQ अन y एक्सिस। अब सपोज ओदेखि एमसम्मको डिस्टेन्स हामीले y2 लियौँ अनि यो डिस्टेन्स y1 भयो ओदेखि एलसम्मको अनि LM भनेको प्रोजेक्सन अन y एक्सिस y2 माइनस y1 हुन्छ विच इज इक्वल्स टु हामीलाई 2 दिएको छ क्वेसनमा यो छ प्रोजेक्सन अफ अ लाइन अन y एक्सिस यो छ। सिमिलरली अब हामीले यही पोइन्ट PQ बाट के गर्यौँ लाइन PQ बाट z एक्सिसमा PR र QS परपेन्डिकुलर ड्रन गऱ्यौँ जसका लागि Z2 माइनस Z1 भनेको प्रोजेक्सन अफ PQ अन Z एक्सिस हुन्छ र जसको भ्यालु 3 दिएको छ। देन वी हेभ टु फाइन्ड द लेन्थ अफ लाइन एन्ड द प्रोजेक्ट एन्ड द डिरेक्सन कोसाइन्स अफ द लाइन PQ। अब जे कुरा हामीले यहाँ फिगरमा लेख्यौँ त्यही कुरा यहाँ अब एक्सप्लेन गरौँ। कन्सिडर अ लाइन PQ, consider a line PQ having endpoints Px1, y1, z1 and Qx2, y2, z2. Consider a line PQ having endpoint Px1, y1, z1 and Qx2, y2, z2. We draw PL and QM perpendicular on y-axis. Then projection of PQ on y-axis equals to LM equals to y2 minus y1 which is equals to 2 is given to us. Also we draw PR and QS perpendicular on Z axis. Then projection of PQ on Z axis equals to RS equals to Z2 minus Z1 which is equals to 3. Similarly, the projection of PQ on x-axis equals to x2 minus x1 equals to 6. Now PQ equals to length of line equals to root over x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square equals to root over 6 square plus 2 square plus 3 square. Therefore PQ equals to 7, which is the required length of line. Also, the direction cosines dishes of line PQ are x2 minus x1 by PQ, y2 minus y1 by PQ, z2 minus z1 by PQ. That is 6 by 7, 2 by 7, 3 by 7 are the required dishes of line PQ. In this way, we have shown that the direction cosines of the line PQ are 6 by 7, 2 by 7 and 3 by 7. This completes your solution.